So welcome to the walkthrough. It's the Edexcel Higher paper. We're in November 2018 and it's paper 3, so calculators at the ready. First up, 1A. It's same to you. 3 significant figures. The third significant figure is the 5, so the number after it, the digit is 7. So that rounds up to 7,360. Part B, would you stick that in your calculator, depending on the make and model, might be safer to put brackets around that, or do bits as you go along. 17 plus 16 is 33, not the trickiest, to help yourself out a little bit. My full display, here we go, 0.1077981,356. Number 2. Joe last year paid. Now, it's one of those situations. It is possible to have a percentage higher than 100, because in this case, as you can see, her car insurance has more than doubled. It's the old formula. Work out the percentage increase, find the actual increase by doing a takeaway, divide it by the original amount, last year's cost. That writes it as a fraction, so you need to times it by 100 to give it you as a percentage. I get 260.408. Call it 260 if you want. I'll go 260.4. Doesn't actually tell us, one of those rare occasions where it doesn't say. 3A. Now, as you can see, I've already drawn it. That's because I've cheated and cut and pasted it from my worked answers, because otherwise I'll just absolutely fluff it with my limited skills on an electronic pen. But let's fill in the table. Now, don't forget it's an x squared, so it's a quadratic, but more importantly for sketching, it's symmetrical. But that's also important for the table, because as you can see, the -2 and the -2 symmetrical. So the -4 just slots in there, so you don't have to worry about subbing in a negative. You can just sub in the 2 and the 3 and reflect it down. So sub in the 2, 2 squared plus 2, take away 4, gets you 2 in there, which reflects to there. The 3's on his own, so 3 squared plus 3, take away 4, I'm getting 8. So job 1, get all those coordinates plotted. There you can see my x's, and get yourself a smooth curve drawn. Mine's not great, but it'll do. Part C, estimate the solution. They sometimes put straight numbers on the end. This one is just a 0. Solutions means roots. It means where does it cross. So the perfect answers are -2.6 and 1.6. Usually allows follow through from your sketch. Question 4, bit of a strange one, kind of a bar chart, histogram, etc., etc. So heights, let's look at that. So yeah, not histogram, sorry, just a bar chart, isn't it? Heights of these bars, because this will come into play. I'll worry about A in a sec. So that's 11. Next one's 8. Then we've got 13, goes up to 6 and up to 2. Work out the percentage or a 20 or more. So it's the final bar, so it's 2 out of, you could add them up, but it's already given you the 40, times 100 equals 5%. Now, part B is a strange way of giving you an estimating the mean. So I've already got these numbers written down, so don't worry about that. But you need them written down because they've given you loads of room over here. Show that an estimate for the mean. Now, to estimate the mean, you normally have a table. That table has frequencies in it. That's the heights of these bars, 13, 6 and 2. And what you need to estimate the mean are your x's, sometimes called your midpoints, depends on what your teachers, which books they've taught from or their personal preference. But no matter what you call them, The halfway points are going up in fives, 12, 17 and 22. And your job is to multiply through 22, 8 sevens are 56, 156, 102, 44, and your job is sigma fx. That means add up that column, we get 380, and the mean is 380 divided by it out of 40, and you get the 9.5, which is what was asked for, because show means do. Number 5, Lara is a skier. Now, as soon as I see a question like that, I always look for, oh, we've got 1 minute 54 seconds. Answer's got minutes and seconds. Now, minutes are a pain in the backside to put into a calculator. So I change that. 60 plus 54, 114 seconds. So Lara assumes the average speed is the same for each race. So time divided by distance gives her speed. Now, because I'm working in seconds here, the answer I get out will also be in seconds. So we've got that divided by that, and that will tell us how long it takes to travel 1 meter. Her next race, we need to times it by 700 meters. And you could do this in any order, by the way, as long as you get 168 seconds, which is 2 minutes and 48. Lara's average speed actually increases the further she goes. So because the 700-meter race is longer than her first race of 475, if you're going faster, the amount of time it takes reduces. So you don't need 2 lines of explanation or waffle there. Just how does it affect your answer? My answer will reduce. Question 6. So it looks like a standard trigonometry rate, Pythagoras or maybe question, but it's got a bit of extra stuff in it. So we know that's 90, so the other angles must add up to 90. So the angle at B is 3/5 of 90. That's 54 degrees. Now I can start using SOHCAHTOA. So it wants work out the length of A to B. So we stick an X, that happens to be the hypotenuse. From my 54, we've got the opposite. So the adjacent is not involved. That makes this a SO question. I want the hypotenuse, so my hypotenuse X is my opposite side, that's 14, divided by S for sin or sine, 54. 3 significant figures, so my answer of 17.304 becomes 17.3. I've cheated for number 17. It's so easy, I don't know why they even bother, if I'm honest. Don't forget, when you plot a frequency polygon, you'll notice my wording's disappeared because I've made my graph larger, so it's easier to see. Basically, as long as you plot the midpoints, that's the middles here, so 5, 15 and so on, and get the heights right, it's 2 easy marks in the bag. Nothing fancy about that. So for number 8, a little bit of puzzle work to begin with, because it hasn't given you the dimensions. Now, obviously, you could call it things like LWH, you could call it XYZ, RST, call it whatever you want. I think it's better to puzzle it through. What goes into 27 and 45? So it could be 3 or it could be 9. But when you start looking at this number on the side, think about the only factors of 15 that are much use because 15's no use, 1's certainly no use, so it's got to be 3 and 5. So you've got to start puzzling out, well, that means it's got to be 3 by 5 or 5 by 3. So by popping that on there, if the height is 5, that's where you get the 45 from. And that also makes sense on the side and on the top. So mucking around with equations for that, I think a little bit of trial and improvement is the best way. So if it gets melted down, how many cubes can we make? Well, total volume of the big cuboid is all that. And volume of the little cuboid is that. Your calc says 8.64. 0.64 is not a cube, so it has to be rounded down to 8. Number 9, they crop up every year. I always do the first two brackets first, so x times 2x minus 2 times positive 3. And the x loops, that's minus 4x, that's positive 3x, so we're getting negative 1x in the middle. I then throw away my expanding mentally and stick with the safety of a grid. I'm running out of room over here, so let's put the x plus 1 over there. So let's times everything by x. 2x cubed minus x squared minus 6x, and times everything by 1. Just write the whole thing down again. Now let's simplify. So we've got 2x cubed. There's our squareds. 2x squared, take away 1x squared, leaves us with 1x squared, minus 6x minus 1x. We're in bigger debt of x, minus 7, and the numbers get plugged in on the end. Next one, find the value of n. So on top, you've got 4 plus n divided by, which means subtract 2, should give us negative 3. So let's do our thinking out loud. 4 take away 2 is 2. So I take away 2 from both sides. N is negative 5. And question C, they've given you a massive clue whenever they say that. And certainly you wouldn't be completing the square. So we know it doesn't factorise thanks to that. Completing the square would be an absolute nightmare. Absolutely quadratic formula all day long. A is 5, B is negative 4, C is negative 3. And I like to do bits as I go along. So minus B means minus minus 4, plus or minus. B squared is 16. Minus 4 times A times C. You've got a minus times a minus. So we've got 5 times 3 times the 4 gives us 60. So when I stick that in my calc, I'll just be hitting 76. All over 2 lots of A. So I do it one by one on my calc. So I would hit on my calc 4 plus root 76 equals, then divide by 10. I get 1.27 to 3 sig figs. And on my calc, 4 minus root 76 equals, divided by 10. If you don't do the equals, do put that in brackets. You should separate numerators and denominators of fractions with brackets. Or like I do the top bit first. Get the numerator sorted, and hopefully you get minus 0.472, 3 sig figs. Question 10. Easier than it looks, really. Just stick things in your calc. Type in 4 times sine 23, and you get 1.56 when it's rounded off as required. Quite a strange one. Here, to find the f of g, do the g of 34 first. In other words, double it and subtract 3. I get 65. And we're now sticking 65 into the equation above, into f. So we need to do 4 lots of sine 65. And again, rounding off appropriately, 3.63. H of x, and we've got Ivan solving it or attempting to. This is not fully correct, because yeah, he's partially correct, because don't forget, you could argue anything here. I know the mark scheme accepts quadratics have 2 solutions, or at the very least repeated roots, and but the best way to show how someone's done something wrong is do it right. So when you square root 25, you're meant to get plus and minus 5. And then when you subtract 4, his answers should be 1 and negative 9, not just the 1. Number 11, I've sketched it already because no one wants to see me be rubbish for 2 minutes and it just to turn out absolute pants. So you need, when you're sketching tan x, you need the asymptotes at 90 and 270. Mark scheme's not fussed if they're solid lines or dotted. They're more fussed about the fact that they're there or not. And when it comes to the sketch of tan x, it's kind of like a cubic, but it's not. So there's a general rising. Don't go cross the asymptotes. Don't do anything daft. But there you go, should level out towards the 180 and 360. Probably a little bit more than the mine did, but it's good enough. It's only worth 2 marks. Make sure you don't do anything daft, really, and they'll give you the 2 marks. Number 12, I've obviously done this paper already, and I've put in anything that can help me avoid using technology. So I've put these purple lines in because that's what's needed. So calculate the size of angle TAC, T to A to C. The way you calculate angles is if you know 2 of the sides of that triangle. So the good news is we already know 1 of them. We're told it's 12. Bit more information, we are told it's a square base and it's 5 by 5, which means a bit of Pythagoras will get us this side here. I'll call it x. So first of all, we can find A to C, because that A to C is the hypotenuse of a right-angled triangle. So we can say that AC is the square root of 5 squared plus 5 squared. You could do it in decimals, but I always do it in decimals, so I'm going to do this one in surds. So I'm going to call it 5 root 2, which means my distance x is half of that, like so. That now means we've got what we're after. If you want to redraw the triangle, they've given you plenty of room. TAC, call it whatever you want, but we've got the opposite and we've got the adjacent. So this is a TOA question. That means to get the angle, it's inverse tan. Opposite is 12. Adjacent is 2.5 root 2. Stick it in your calc. Doesn't say how accurate. Let's just be sensible. I've gone for 73.6 degrees. On we go. Question 13. Not very nice terminology, but actually a really nice question. What does this P? Doesn't matter. It means to get next year's number of animals, you times, so there's next year, you times the current by 1.01. So 400 times 1.01, that gives us the population for year 2. And if we times it again, we get the population for year 3. And there we go, that's it. Nothing more complicated. 408.04, but because it's animals, nearest whole number. Question 14. Inverse proportion. It's a strange one, this x equals a, but my old argument of do what you should do. If they gave you a number, if they told you x was like 6 or something, what would you do? Well, carry on doing it. Just because it's giving you a letter doesn't mean you shouldn't just track on. So, y is, I'll use c, inversely proportional to x cubed. Y is 44 when x is a. It's weird, but go with it. Which does mean c, when we multiply both sides by a cubed, c is 44 a cubed. You don't need the times. Which means you've got the formula. Y equals, and all we do is we go back to the original equation, but we've now got the value of c, kind of. The value of c is 44 a cubed over x cubed. Show that y equals 5.5. We just need to replace x equals 2a. So we keep the 44 a cubed. We're going to replace the x cubed with 2a, all cubed. When you cube 2a, you get 8, and you get a cubed, and they cancel. You're left with 44 divided by 8, which is, guess what? 5.5. Number 15, prove algebraically. Now, these are hard to start, but you've got to remember when it comes to these sort of proof questions that even numbers are of the form 2n. And so that's an even number. What's the next even number? 2n plus 2, 2n plus 4. Or if you want the previous even number, 2n minus 2. Well, if that's an even number, 2n plus 1 is an odd number. Difference means subtract. Squares. So that's my even number. I'm going to go for that's my odd number. The one that precedes it is 2n minus 1. Didn't have to go for that. Could have gone for 2n plus 3. Either way, they are consecutive. And once you've got it set up like that, it's just about how good is your algebra. Can you expand those brackets? Because, trust me, this one ends up really nice. So, square the first, square the last, times the two together and double it. Do the same here, but don't forget it's timesing by a minus 1. So square the first is 4n squared, but it's a minus. Square the last is positive 1, but it's a minus. Times the two together and double it is minus 4n, but it's times by the minus 1. We get plus 4n. And guess what? Loads of stuff disappears. 4n squared minus 4n, positive 1, negative 1. I end up with 8n. If you'd have gone for a plus 3 there, you would have still got a multiple of 8. Don't worry about it. All right, could have had 2n plus 11 and 2n plus 13. They're consecutive. You would have ended up with a multiple of 8. So multiple of 8, well, look what I've got. N can be any number, so 8 times n must be a multiple of 8. So the algebra is what the argument is required, but they do always like a little bit of reasoning after it. So do put a few words in, 2 or 3 words, like must be a multiple of 8, just to wrap it up nicely. So number 16, you've got this weird looking shape here. No labels on it, but they have given you, so let's get the information on. The shape is made center O and radius 6. Let's get it on. AD is 14. Angle AOD is 140. That's 24. Oops. And in case you needed it, that's 16 as well. So once you've got that bit of information, it's a case of how do you work out the perimeter of the shape? Well, the perimeter of the shape is going to be the length of this arc. Added to 14. So really the pain is knowing the distance C to D. That is the problem, because it's not known. Once we know CD, we can add it all up. We can just do a bit of calculations for the arc, but we need C to D. Now, C to D is not the side of a triangle. O to D is, because if we found O to D, we can just take away 6. So that's the key. How do we find O to D? Well, we've actually got this triangle. O to D is opposite the 24. So we can find O to D, sine rule. O to D divided by the sine of 24 equals, and that's the 14 divided by the sine of 140. And you should get OD spits out at 8.8-ish. 587 I've got. But more importantly, that tells us what C to D is. If we take away the radius, minus 6, we get 2.8587. And we can now crack on with the perimeter. The perimeter is A to D, that's 14, plus C to D, we've just found it, 2.8587, and we've got the arc A to C. Well, the length of an arc is, we take the perimeter, the circumference of a circle, 2 times pi times the radius, multiplied by, now the angle we're interested in is not the 140, it's 260. 260? 220, sorry. So it's 220 degrees out of the 360. So bash all that into your calculator. I get 39.909, or in other words, 39.9 to 3 significant figures. So as you can see for number 17, already cheated by drawing it, but let me show you how I did all the calculations. The key thing with histograms is frequency means area. And 0 to 20 means you have your widths. 20, 30, 30 and 70, and 50 on the bottom. So to work out your frequency densities, think of them as heights. So do area divided by width, you get height. And just carry on. They all turn out to be nice whole numbers. So as you can see, I put little notches on the widths. Out comes my ruler. I label my frequency density. 6 was sensible because they've given you a little bit more than you need, but I've gone with 6. You could have halved it, but it gets a little bit fiddly. And so get the heights and just draw them as you would normally with the heights and the widths. Estimate the median. Now, there's different ways of doing what's basically called linear interpolation. So I've looked at cumulative frequency, so let's add up the frequencies as we go along. Now, half of 570. All right, we are looking for the 285th. What group, what bar are they in? So the first group, up to the end of the first group is 120. We add on 90, so there's 210. We add on 120, we get 330. So our median is in that bar there. And we are targeting the 285th person. So here's how I go about this calculation. The lower limit for the median is 50. So we need to add a certain amount onto 50 for our estimate. The question is, what do we add on? Well, the width of the class from here to here, the width of the class is 30. So we need to add on a certain amount of 30, a certain fraction of 30. The question is, how much of a fraction? Well, the group itself accounts for 120 people, students, and we are 75 students in to that section. And that's how I do that form of interpolation. Stick that in your calc and you get a very sensible, respectable 68.75. The method is slightly different in different textbooks, certainly different at A-level and so on. There's a couple of very strong methods there, but that's the way we're going with it for today. Number 18. A lot of people don't like bounds. I say get your teeth into it, just go get on with it. High-speed train, 487 kilometres. It's to the nearest kilometre. We need to go up and down by half a kilometre. We've got 3 hours. To the nearest minute, let's work in minutes. 180, nearest minute, so up by half a minute, down by half a minute. By considering bounds. So it doesn't tell us whether to go for the upper or lower. So in other words, we must do both. So we are considering our distance, speed, time triangle. It wants the average speed. So we're needing to do distance divided by time. So upper bound. To get the largest possible amount from our answer, we need the largest possible distance divided by the smallest possible time. Now this will, because we've changed it to minutes, this will give us kilometres per minute, but that's actually what we're after. So 2.715877 kilometres per minute for our upper bound. Our lower bound, that means we need the shortest possible distance divided by the greatest possible amount of time, and that gives us 2.695 etc. kilometres per minute. Now it's leaving us to our own devices, to our own logic. By considering bounds, work out an average speed to a suitable degree of accuracy. Now, if you look at that number there, 2.7, and that number there, 2.7, if we round both to 1 dp, we get 2.7 kilometers per minute. That is a sensible degree of accuracy. That is a sensible, because your upper and lower bounds are the same to 1 decimal place. That's a good answer. On we go. Number 19, so we've got simultaneous equations with quadratics. So your choice, you could write y equals, but I wouldn't, because writing x equals 1 minus 2y is much easier than having y equals 1 minus x all over 2. That becomes a bit messy. So I'm going to take this and substitute it into equation 1. So 2, and I'm replacing the x with 1 minus 2y. So we've eliminated the x's. We now just need to form a quadratic. Hopefully it's nice. I've done this already. I know it's not nice. But here we go. To expand these brackets, but as you go, double them. So square the first, doubled. Square the last is 4y squared, doubled. Time them together and double it is minus 4y, but we're doubling. And then we've got the minus y squared on the end. Let's simplify and equate to 0. So 8y squared minus 1y squared is 7y squared. So it's not friendly, but at least it's a prime number. So we've got 7y and y in our brackets. Then we've got minus 8y. And we've got 2. Take away 17. We've got minus 15. So you could use the AC method, but because, as I say, that's prime, I use the educated guesswork. So it could either be 3 and 5 here, one of them being a minus, but actually it turns out y plus 1 and y minus 15 get you there. As I say, you could spend a bit more time on that, but I'm fortunate in that I've worked through this paper already. So we get, I'll do the easy answer first. Y is negative 1. Well, obviously the easier of the two equations is the second one. So in it goes. So my x equals 1 minus 2y, 1 minus 2 times minus 1 means 1 plus 2. We get 3. And calcs at the ready for the next one. Y equals positive 15 over 7. But follow the same process. Y, x is 1 minus 2 lots of 15 sevenths. That's why you get your calcs out. We get minus 23 sevenths. Be careful how you write your answer down at the bottom. X equals 3, y equals minus 1, and, or put a slash or something, another comma can get messy. X is minus 23 over 7 when y equals 15 sevenths. So as far as quadratic simultaneous equations goes, reasonably standard. Question 20, again I've cheated, but let's just talk ourselves through it. So take the shape, rotate it 180 around that coordinate, minus 2, 0. So you could ask for tracing paper. I've done it by counting. Left 1 up 1 becomes right 1 down 1, and so on. There we go. Then it's translated. That means left 3 and up 2. And it finishes there. Now comes the weird bit. 1 point is invariant. Don't forget, varied means different, it changes. Invariant means it stayed exactly the same. Now, it's not those vertices. They've basically switched around. They have changed. The only point on the triangle which hasn't moved is the center of that edge there. And that center has the coordinates -3.5, +1. Now, obviously, the big, harder end questions were earlier than this, but that wasn't as straightforward as it could have been. But there we go. So I hope that helps. That's another set of papers ticked off. Hopefully, I'll see you on the next one.